Hi. So yeah, thank you. Thanks for coming. So what we were discussing in this sort of few systems that we are discussing. So in the first case, like when we are dealing with the model system, so the way it is, I just mentioned here, like the states of a model system. So in this, we just talked about that how a model system can be constructed effectively. So we have seen that, right? Uh, a few particular model system. Yeah, so in a two-level system that we talked about, so is this a binary mixture sort of thing? So, and we are talking about the spin configuration more like in kind of a Ising chain. So the n particle scenario can be something thought of like all spins can up. That's a possible one configuration, that when you have all spins up. And इसका just like there could be a many configuration that we can think of. तो पहला एक हम case consider कर सकते हैं. So the number of distinct configurations will be just as we know, like in the binary mixture case, we have seen, right? देखा like you can break it down in up and down, and you can find out the 2 to power n is a total number of configurations for a binary spin system. So now exactly what will be the probability of finding a particular arrangement in out of this 2 to the power n configuration is 1 by 2 to the power n, right? That's obvious thing. And so now let's talk about few facts. I mean, few just one-liners. This thing just I mentioned you right already that how can we calculate the total magnetic moment of this chain, like this Ising chain? n spins हैं वहाँ पे. And पहला केस क्या है कि जब सभी spins up हैं, then the magnetic moment is something all up. And when one down, and this is the magnetic moment with one down, you can possibly think of how this one down scenario works, right? I last time I explained to you. Then the two down with the possible thing is that the important thing to take over is that key with all like one down ke saath, there is a fact, there's a even number of minus sign that's coming, like -2, -4, and so on. Those sort of scenarios appear. सो जनरल एक्सप्रेशन जो पिछली बार ड्राइव किया था वो कुछ ऐसा था कि लेट्स अज्यूम अ सिंपल सिचुएशन व्हेन n टर्न्स आउट टू बी इवन नंबर, and then the up spin is something like n by 2 plus s, and the down n is this, and then the 2s is associated with the spin excess. And this for a two spin configuration, we have seen that how this spin excess work, right? In this case, जब सभी, like you can calculate it from here, right? जब सभी up हैं, so yeah, there is no down. So this turns out to be +2. This is 0, 0, and this is -2. So it lies between, the set lies between +2 to -2, right? That's all the cases is. And for the general expression n spin system के लिए अगर हम इसी expression को divide करना चाहें, so since it's a binary mixture, so binary model system में there's a one thing is that you can always invoke your binomial expansion, and you can see that the general expression is for n particle is something like this, right? So then you can define your multiplicity function GNS here. So GNS is something like with the spin excess form I written is t replaced by n by 2 minus s से कर दिया. तो जनरल जो एक्सप्रेशन है GNS का कुछ ऐसा दिखता है, right? Factorial n by 2 plus factorial n by 2 minus s factorial, or maybe this you can say that the n1 is up and n2 is down and so on. So the general expression ऐसे करके दिखेगा. And so let's also discuss what binary mixture is exactly. It's a kind of alloy which a1 minus x bx, the total number conserved. So a spin a terms कितने होते हैं 1 minus x, and b x xn, where x lies between 0 to n. तो अगर इस केस में you can find out the multiplicity function, which is exactly the same what we had derived. This is the multiplicity function, right? G and t for case of binary mixture, right? This is your multiplicity function, right? So abhi behavior, the most important thing is that in this scenario, that to discuss the how for a very large system, like that's what we are interested in, statistical behavior, right? कि बहुत ज़्यादा जब n is greater than very 1, तो क्या ही how this function will look like. So in those sort of cases when n is much greater, then it is always good to good to go with the log of these functions rather than the individual functions. So if you take the log of these functions, then log GNS is log A by B, log A minus log B. Like now when, since n is very large, so you have to make a factorial and approximation, which is basically your Stirling approximation. You can see 2 pi to power n to power half n to power n exponential minus this is your Stirling approximation. You invoke this expression, take the log of this entire seventh equation. Once you take the log, you will get this expression 1 by 2 log 2 pi 1 by 2 log 2 plus, and this is similarly this is for total number of particle, and you are taking log. This is, let's say n1, assume n1 have a spin up, then similar way you can write log n1, similar way you can write log n2, and now you plug these things into this GNS expression. Once you do that, you will see that the log g turns out to be given by equation 13, right? So that's where log g turns out to be 1 by n minus n1 plus half log n1 n2 plus half, right? This sort of scenario. So log n1 by n1 n को हम ऐसे भी deal कर सकते हैं कि n1 is something like in spin excess terms, it's basically n2 by s, right? And n divided. So now if you divide it by n, this entire, so this, and take 1 by 2 out of this, so log 1 by 2, 1 plus 2s by n. Now this minus log 2, then log 1 plus 2 by s. And now this, since s by n will be much less than 1 because n is much greater than 1. So you make an expansion of log 1 plus x, something like the way series works, x much less than 1, the log 1 plus x series, right? That's basically x minus x square by 2 and so on, right? So वो यहाँ plug कर दीजिए. And then after some calculations, you can, I mean, it's a very minor algebra, 1-2 step. You can see GNS basically is, for a very large n cases, behave exactly like a Gaussian probability distribution, which is sharply peak around s equal to 0, right? So you will see that the probability of finding the particle with no spin excess is much higher than the higher version wala, right? For example, all spins up, all spin down can just comes out just in a one combination, but you will see that the do wala comes with the two-fold degeneracy, teen wala comes with the threefold. So aise karke, so that's because of, for a large spin behavior, you can see that how the Gaussian function behave. So I think let's आज के लिए मैं इतना ही रखूंगा, फिर मैं next time पे I will explain much on the further things. Thank you. Yeah, thanks.